Hi, this is Jed Salazar at Edera. Today we're going to be discussing the very fascinating incident between the OpenAI and Hugging Face production platform compromise. So if you're unfamiliar, the TLDR is that OpenAI had an unpublished agent in conjunction with other existing agents. I think it was GPT, Sol. And these agents were operating with a specific objective, which is to work on the exploit gem set of tests, like a benchmarking suite for how capable a given AI model is for taking vulnerabilities and being able to exploit them. So while it was working through this, instead of actually going through and conducting the tests, the way that we would expect it to, it decided to cheat on the test. And the way that it was going to solve this exploit gem assessment is by basically breaking out of its environment and finding where the source of the answers are, which in this case was the Hugging Face production environment. Let's dive a little bit into how that occurred and how Edera thinks about this and things that we can do to actually maybe even solve this. So really quickly, I'm going to walk through a quick demo. I'm going to set this up a little bit. So first off, what we've done here is we've kind of recreated this exploit gem scenario where we have maybe an AI agent, with the frontier model. It's highly advanced, levels of sophistication to be able to chain multiple vulnerabilities together and actually look almost like a nation state to be able to carry out long campaigns to compromise an environment. So in this case, that environment, looks like something like the Hugging Face platform. The question kind of then becomes, how do we fully isolate and sandbox that AI agent? So even if we kind of, have an alignment problem where we ask it to do something and it, decides the best way to achieve that thing is to compromise a third party, how do we kind of keep that thing constrained? So, we keep that, code trusted and we don't, allow bad things to happen. So we have this setup here where we have kind of a example environment where we have, the agent that's running, and we have a couple of additional components here. One of them is proxy. Now, if you read the report, one of the things that had a zero-day vulnerability that kind of was the first stage of this attack. Now, there were multiple stages, but the first stage was there was a container or a package registry that got compromised. And this package registry was there to allow the agent to install certain types of software, like if it needed to run apt-get or pip install. It could do so from this isolated and quote unquote sandboxed, proxy. That meant that it didn't have direct access to the internet to basically, theoretically sandbox it. So what we have here is we have this agent, and we also have the proxy that's running as a standard container. We also have that same proxy that got compromised. It's running inside of an Edera zone. So we can kind of showcase what happens when you introduce Edera into the world of untrusted AI agents and try to sandbox these agents. So first off, we're going to basically just run a quick test to show you that the agent shouldn't have unfettered access to the internet. So it's trying in this case to actually just reach out straight to huggingface.co and it gets blocked. So in this case, there's a little bit of a concept of a sandbox because this agent doesn't have direct egress access to the internet. However, in this incident, what it did is it, again, looked at its sandbox environment and asked, can I compromise it? So what we're going to do here is we are going to showcase a poison artifact. So we're going to basically find a vulnerability in this agent control. We're going to take advantage of that vulnerability. And what we're going to do is we're going to exploit it and then perform some privilege escalation and eventually some lateral movement to be able to go out and attack Hugging Face's network. Let's see how this works. So when we run this exploit, we can see here that there's a lot going on. Let's walk through this. First off, we have what happened after the exploit, and we can see that we got full remote code execution, which we see here is running as user ID 0 as root. So we exploited the pickle. We had this deserialization. We got the remote code execution, and now we're running as root. What do we do with that? Well, the first thing that we do to kind of validate that we can successfully privilege escalate is that we move to root on the node. And in this case, the way that we can prove that is we have this secret canary file. This file exists on the host, which container should not be able to read. It should be fully isolated from the host. However, because we were able to escalate as user ID 0, we in fact are able to read that canary. So that's been compromised. The script then further goes on to perform some lateral movement. And in specific, we're going to be stealing a neighbor's token. So we're actually coming from this team where this pod is running in a team's payment space. However, we want the service account credentials and the production database resources from the analytics team. That lives in a different container, but because we have full control over the system, we're able to get both of those things. So you can see that we basically are able to read all the secrets, including this production database credentials as well. And we're able to basically fully laterally move and compromise the environment from here. So this is kind of an example of how these attacks work. Is you find a vulnerability. If it's severe enough, then you basically get remote code execution, and kind of everything is compromised. Now, what we can do is, even without isolation, we can perform some intrusion detection. And in this case, we're running Falco, which is a pretty typical security monitoring agent. And you can see here that Falco did indeed at least detect that all of this behavior was happening. And in fact, what hasn't been answered because we don't have the logs is how sophisticated from a hiding itself perspective and it's kind of stealth perspective was this agent carrying out this attack. In this case, it wasn't very sophisticated in trying to hide its behavior. We see a couple of these warnings, like, for example, this untrusted deserialization remote code execution. However, we also see this host code, this host canary that we had on the node, not inside the container, that shouldn't be accessible from the container. We see that this was in fact exfiltrated from the compromised proxy that ended up becoming root on the host. Now, what we're going to do here is we're going to carry out the same exact attack. However, we're not going to carry it out against the proxy that's running inside of a standard container. We're going to carry it out against the proxy that's running in Edera. So let's see what happens here. So same serialization attack, same pickle, all of those different things. Great. And in this case, what we see is, so we were able to run the deserialization. We still got remote code execution. And in this case, we still have user ID 0. However, there's a crucial component that isn't immediately shown here, and that is that when you run inside of a zone, that's actually a fully hardware isolated virtual machine environment, a micro VM. And what that means is we have our own dedicated kernel. That means that even if we compromise this machine and become root, or even compromise the kernel itself, we still will be completely isolated from the host system itself. And we can see that here. We tried to actually access the host canary, and we're unable to do that because it's completely isolated. Additionally, we were unable to laterally move throughout the environment and then capture some of the credentials from other teams that reside on the same node. And crucially, we're unable to move forward to actually be able to compromise further environments, including Hugging Face. Now, is this realistic? Yes, it is. Inside of the Hugging Face production environment, one of the things that was compromised during this attack that was published was that there was a code processing application, and that code processing application was compromised, and it did escalate to actually be able to get node level access to the system. So this attack is exactly what happened on the Hugging Face side. And this is one of the components that the AI agent took full advantage of. Now, because we're running inside of a zone, we have full isolation, but that doesn't mean that we should sacrifice visibility. We should still be able to identify, security monitoring and basically, get the same type of events that we would have gotten. And you can see here that we have the same level of visibility, so we don't lose out on that visibility. But crucially, we can see here that even though this attempted attack happened, and we have this, untrusted deserialization remote code execution, and we have this, namespace breakout attempt. Those all happened, but they were confined to the host itself, which means that the host canary read was unsuccessful. So we were unable to exfiltrate any of the credentials. We're unable to take those credentials and laterally move throughout the environment. And for all intents and purposes, this attack was unsuccessful. So that's one way that isolation is part of a newer trend that's necessary to secure these AI agents. If you've been part of the conversation, you know that AI agent sandboxing is a very important component, and we are very much at Edera involved in that AI sandbox isolation conversation. If you'd like to know more, feel free to reach out. But yeah, thanks for watching. Cheers.